Hello everybody and welcome to the homework helper for section 1.2. Let's go ahead and dive into what we're going to be doing here today. The very first section wants us just to solve for x. Some of these are easier or harder than others, and a lot of them really depend on how much you remember from your previous algebra and geometry experiences. So I'm going to go over some of the more challenging ones first and kind of leave maybe some of the easier ones to you for your homework. So when I think of one of the more challenging ones, I definitely think about number 2 here. Number 2 is a very complicated mix of different polynomials. We have x squareds, we have constant numbers, and then we have x's. So what we want to do first and foremost is we want to kind of combine our like terms. So when I think about combining my like terms, I want to get everything on one side of the equation first, just to kind of see what it looks like. So I'll start by subtracting 2x squared from both sides. And if I subtract 2x squared from both sides, that'll cancel, leaving me with a negative 5 on the left. 3 minus 2 is 1x squared. And then I just copy down everything else, minus 12x plus 31. I then want to get that negative 5 cleared so that it's on both sides. To do that, I'm going to add 5 to both sides, add 5. So this gives me a 0 equals x squared minus 12x plus 36. Okay, now I have it written as a quadratic trinomial. All right, so this is the sort of thing we would do if we were graphing parabolas, for example. So when I look at this quadratic trinomial, what I'm trying to do is I'm trying to solve for x. To do that, I need to factor this down, right? This is kind of like the foiled version. Remember first, outer, inner, last? We're going to be unfoiling it, so we're going to be factoring it down. The way that I like to think about factors first and foremost is we need to, this is our b term, this is our c term. And so what we're looking for is we're looking for two numbers that add to be our b term, but multiply to be our c term. So what we're looking for are two numbers that when we add them together are going to be negative 12, but when we multiply them together are going to be 36. This is kind of challenging though, right? This is not an easy thing to just come up with on your head. So one of the strategies that I use to try to think about this is I factor 36 first. And I know that they have to add to a negative 12. And so if they have to add to a negative 12, but multiply to a positive 36, I know that these are both going to be negative numbers. So like negative 36 times negative 1 will be 36, but those aren't going to add to negative 12. Negative 12 times a negative 3 are going to multiply to be positive 36, but they definitely don't add to be a negative 12. And I'm going to keep kind of repeating this process for a little bit, but I'll definitely see that eventually negative 6 times negative 6 are going to be a positive 36 and are going to add to negative 12. So negative 6 times negative 6. Okay. Now that I know that that's true, I can start to fill in a little bit. So I know that 0, I'm going to write it up here so I don't have to use another sticky note, is going to be x minus 6 times x minus 6. Well, this is squared, right? So this is x equals x minus 6 squared. I can take the square root. Square root of 0 is 0, meaning 0 equals x minus 6. Add 6, add 6, 6 equals x. I've solved for x. That's a really complicated problem if you don't remember your factoring rules. Okay, this is something that I touch on at the end of Algebra 1 just a little bit. Might come up in geometry, I'm not sure, but definitely one of those higher order thinking processes. Okay. Something a little bit more in the range of what I want everybody to be able to do is number 3. So when I see this, I have a radical on the right side. I want to get x by itself. To get rid of that radical, I need to square it. When I square 111, or I'm sorry, when I square 11, okay, I take 11, I square it, I get 121. So I know that 121 equals 2x plus 1. Because by squaring the whole radical, it undoes that radical, right? The square root of something squared is that something. From here, I just subtract 1, giving me 120 equals 2x. Divide by 2, 60 equals x. Boom. And then similar processes will work here. We'll square both sides and then try to use this method that we used. This one is a cube root. So instead of squaring both sides, we're going to cube both sides. Okay, so we're going to multiply -4 by itself, etc. Now let's look at these ones down here. These ones are going to be a little bit more challenging if you haven't played around with logarithms yet. But let's just think about it in terms of what's happening here. So I have 9x equals 243. So 9 to what power is going to equal 243? That's the question. Well, let's think about what our 9 powers are. Like 9 to the first power is 9. Clearly that's not 243. 9 to the second power is 81. That's not 243. And then 9 to the third power, well, I don't know what 9 to the third power is off the top of my head, but when I put it in my calculator, I see that it's 729, which is way more than 243. So one of the things we do know is that the power we need to raise it to is between 2 and 3, but that doesn't necessarily help us. We know that it's between 2 and 3. What can we do to actually figure it out? Well, one of the things we can do is recognize that 9 itself can be written as a power, right? 3 squared is 9 because 3 times 3 is 9. So this is actually 3 squared to the x power. Now, when we have a power being raised to another power, that's the same as that power being multiplied to that power there. So it becomes 3 to the 2x. So now 3 to the 2x is going to equal 243. So now I'm going to try this again, but this time with my powers of 3, right? 3 squared is 9. 3 to the third is 27. 3 to the fourth, this will be 81. 3 to the fifth, 3 to the fifth is 243. So now that I know that 243 is really 3 to the fifth, I have this expression right here that's going to help me find x. Because if 3 raised to this power is the same as 3 to raise to this power, that means these must be the same power. So I know that 2x equals 5, or if I divide by 2, x equals 5 halves. And I can actually check that back into our original. If I take 9 and I raise it to the 5 halves. So if I take 9 and I raise it to the 5 halves, this should give me 243. And sure enough, it does. A lot of steps to get there, but we got there. Now for number 8, another exponent rule that we need to think about is that any number to the negative power, -1 power, is going to be 1 over that number. Okay, it's going to be 1 over that number. So when I see this, when I see 1 over 25, immediately the thing I think of is that's actually 125 to the -1st power, right? It's to the -1st power. And likewise, this 1 over 32, well, that's 32 to the -1st power. So now I'm trying to see 5 to what power is 125? Well, I know that 5 squared is going to be 25, but 5 cubed is 125. So I know that 5x is going to equal 5 cubed to the -1 power. That means, again, if a power is being raised to another power, those powers will multiply. So 5x equals 5 to the -3rd. X equals -3. Okay. Bit of a challenge, but as long as you know your negative exponent rules and you take it step by step, you'll be able to get there. Next problem. Students were given a set of data to graph. After they had completed the graphs, each student shared his graph with his shoulder partner. When Ethan and Emma saw each other's graph, they exclaimed together, your graph is wrong. Neither graph is wrong. Explain how they got this different data. And what I want you to do when you're thinking about this problem is think about what we went over in class as part of our lesson today. We were talking about the Ferrari and how does that behave? How does the speed and distance? Think about that when you answer this question. Explain how they neither got it wrong. Next, number 12. A baseball is hit upward from a height of 3 feet with an initial velocity of 80 feet per second, which is about 55 miles per hour. The graph shows the height of the ball at any given second during its flight. So use this graph to figure out what's going on. It says approximate the time that the ball is at its maximum height. So what time is this here? And then approximate the time when it hits the ground. What is this time here? And then at what time is the ball 67 feet above the ground? So figure out where 67 is. It's a scale of 5. So what is that? 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 65. So it happens here and it happens here. Okay? And using all this information, it's going to want you to take it, make an XY table, right? XY tables will help us try to figure out what's going on. And then we're going to think about it as an inverse here. So flip your table at that point, make it y, x, and then change it so that now we have the height, which was the y, becomes the x. We invert it, and then likewise, this becomes inverted as well, and we'll get to see what that looks like. We'll get to see how that looks. All right. Next up, getting parched here. Okay, so again, we're going to be using more function notation in evaluating our functions. This time we have an f of x, a g of x, and an h of x. So all we're going to be doing is plugging in these values. So f of 7 means we look at f of x. It was 3x, but now we're plugging 7 in, so it's 3 times 7. So that's going to be 21. We're done. G of x, we're going to take 7. So this is going to be 10 times 7 plus 4, 70 plus 4, 74. We're done. Okay. Let's look at our more challenging problems, s minus t. So this is going to be 3s minus t. Distribute 3s minus 3t. We're going to do it again for g of t here. So this was 10 s minus t plus 4, 10s minus 10t plus 4. We're done. But when we look at h is a little bit more complicated because we have a square here. So when I look at h of 7, this suddenly becomes 7 squared minus 7, right? X, 7 is our x. So that's 49 minus 7, which is 42. But it really gets complicated when we start doing a binomial instead. So this becomes s minus t squared minus s minus t. Okay. First of all, I want to start with this minus here. When we're subtracting from this binomial, it's like there's a negative 1 being multiplied here and here. So when we rewrite this, negative 1s is negative s. Negative 1 minus t would actually be a negative times a negative, so that's going to be positive t. But now we have this binomial here, so we need to FOIL that out. And so when we FOIL out a binomial, remember we're doing first, outer, inner, last. That's what I mean when I say FOIL. First, outer, inner, last. So it's s minus t times s minus t. So we want to do our first terms. Let me scoot this up. Our first term is s times s, which is s squared. Outer. S times negative t is minus st's. Inner. Negative t times s is minus st's. Last. Negative t times negative t is a positive t squared. These terms combine, giving us st minus 2st plus t squared. So now that we know that, I'm going to factor that in here. This is actually s squared minus 2st plus t squared, and then minus s plus t. Complicated steps here. These will be complicated because we're using the squaring. And then these problems here will be complicated because we're using a binomial. We're using s minus t to plug in for our x's instead of just a number. So just be mindful of that. That's going to be a challenge. Okay, the last problem I want to do is number 25 here. So what this is asking us to do is look at this notation here, f, and then instead of an x, we're putting g of x in. So this indicates we're replacing x in f of x with g of x. So previously, we would plug 7 in to our f of x equation, or we'd put s minus t in to our f of x equation. This time, we're going to take all of g of x and we're going to plug that in to the x. So let me rewrite it down here. So f of x is 3x. Let me scoot it up just a little bit more. G of x is 10x plus 4. And so what we're going to be doing here is where our x was, we're going to be putting g of x in. So f of g of x equals 3 times g of x. Okay? Except we know g of x actually means something. G of x actually means 10x plus 4. So instead of writing g of x here, I can instead write 3 times 10x plus 4. And now I can simplify and evaluate it. I'll just do it right up here. This becomes 30x plus 12, right? 3 times 10 is 30. 3 times 4 is 12. So I would say f of g of x is 30x plus 12. We took one function and put it into another function. Sometimes you can kind of hear the way that I say this, f of g of x. Sometimes we might write it a little bit differently. We might say f, and then we'll use like a little tiny O circle of, kind of looks like that, g of x. Sometimes we might abbreviate this as like fog, because it kind of looks like the word fog. But what we're really saying is f of g of x. These notations are saying the same thing. They're just two different ways of saying it. F of g of x, f of g of x. And they would both be 30x plus 12. So when you look at 26 and 27, excuse me, here we're going to be putting the h of x equation into the f equation to see what we get. And here we're going to be doing the f of equation, put that into the g of x equation and see what we get. So it's going to be some complicated steps, but I believe in you. You guys can do this. And thank you very much. See you next time.